The next video is about the internal structure of Earth. Let's start. Okay, so in the previous video we discussed why sound waves travel faster in denser medium while night waves slower. It is because the sound is a mechanical wave which goes with compression and rarefaction. So this is the compression and the rarefaction. We'll start with the internal structure of the Earth. So as we know that the Earth is made up of various concentric layers. These are the concentric layers, and the outer layer is crust, inner is mantle, and then core has two parts, outer core, inner core. Though mantle also has many parts, but just for a broader perspective, crust, mantle, outer core, inner core. That's what given in NCRT also. The crust is a silicate solid, the mantle is a viscous molten rock, and the outer core is a viscous liquid, while the inner core is a dense solid. So I think it could be a perfect question for your prelims where they can confuse you with some statements. So better we remember it as like a crust. It has um, the NAND form. So it is silicate solid. The mantle, it has magma. So it is a viscous molten rock. Outer core is having this liquid. So this outer core is the liquid part, while the inner core is a dense solid structure. Mechanically, Earth layers can be divided into lithosphere, asthenosphere, mesospheric mantle. As part of the Earth's mantle, below the lithosphere and the asthenosphere, outer core, inner core, and chemically, Earth can be divided into crust, upper mantle, lower mantle, which I was discussing earlier. That mantle is also divided into parts, and outer core and inner core. So, coming for the crust, crust is the outermost layer of the Earth, making 1% of the Earth's volume and less than 1% by mass. Density increases with depth. A good question can be asked from this: how density increases with the depth. The thickness of the crust varies in range. So, somewhere there will be mountains, somewhere there would be ocean, somewhere there could be continental crust. So, 5 to 30 kilometer in case of oceanic crust, and 50 to 70 kilometer in case of continental crust. So, continent have more thickness as compared to ocean. A good question can be asked. So, in every points there would be some hidden questions. We'll try to explore them. Continental crust can be thicker as 70 km. Where mountain systems are there, it is as much as 70 to 100 किलोमीटर thick in Himalayan region. और जो हमारा टेम्परेचर है क्रस्ट का वो भी डेप्थ के साथ इंक्रीज करता है. सो विद द इंक्रीजिंग डेप्थ the density also increases and the temperature also increases. And this is the reason why we are not able to drill into the inner core, because temperature is making it impossible for the manual research. The temperature increases as much as 30 degrees Celsius for 1 kilometer. So for 1 kilometer, if 30 degrees Celsius is increasing, just in the upper part of the crust, think of the core. The outer covering of the crust is the sedimentary material. So when the magma erupts, it will be primary, then secondary. Sedimentation will occur, so it's a sedimentary material. Below and lie crystalline igneous metamorphic rocks which are acidic in nature. So all these rocks, there's a separate chapter for that when you learn which is acidic, basic, all these things. So for just now, we say that the outer covering of the crust is of sedimentary material, and below that all igneous metamorphic rocks are there which are acidic. Below this, it will be basaltic और अल्ट्रा बेसिक रॉक. सो पहले बेस आएगा देन एसिड. अभी जो कॉन्टिनेंट्स हैं इनमें सिलिकेट्स और एल्यूमिनियम का कॉम्पोजिशन, इसलिए इसको सी आर बोलते हैं. सो इट इज़ कॉल्ड सी आर. जबकि ओशंस के अंदर सिलिकेट्स का क्वांटिटी ज़्यादा है अलॉन्ग विद मैग्नीशियम, सो इट इज़ कॉल्ड सीमा. सो कॉन्टिनेंट्स के लिए सी आर और ओशंस के लिए सीमा. कॉन्टिनेंटल क्रस्ट के अंदर सोडियम पोटेशियम एल्यूमिनियम सिलिकेट, ओशियानिक क्रस्ट के अंदर माफिक दैट इज मैग्नीशियम सिलिकेट लाइक बेसाल्ट. तो कॉन्टिनेंटल क्रस्ट में ग्रेनाइट, ओशियानिक क्रस्ट में बेसाल्ट. ओके नाउ ये एक पोटेंशियल क्वेश्चन था जो मैंने किसी टेस्ट सीरीज में देखा था. मोस्ट अबेंडेंट एलिमेंट्स ऑफ अर्थ क्रस्ट, सबसे पहले ऑक्सीजन, सबसे नीचे मैग्नीशियम. अगर इतना ऑर्डर भी याद है इट्स वेल एंड गुड. या फिर मेजर आप इनका याद कर सकते हो विच इज़ गिवन इन एनसीईआरटी. OCR FeCa, OCR FeCa, that's all. Oxygen, silicon, aluminium, iron, calcium, and this is by weight. Okay, so this is in the decreasing order, descending order. Diagram for that. अब मोहो डिसकंटिन्यूटी. सो जैसा कि हमें पता है कि द क्रस्ट एंड द एस्थेनोस्फियर दैट इज द अपर पार्ट ऑफ द मेंटल. तो इसमें there is discontinuity in the seismic velocity. It is thought to be change in rock composition from rocks containing feldspar to rocks that contain no feldspar. Now, this is not a part of NCRT, so it's okay if you leave also, but you can just, if a statement comes why MOVO discontinuity, it is because of the change in the rock composition. That is also enough to solve any basic question if it comes containing the feldspar above to the rocks that contain no feldspar below. So ऊपर feldspar रहेगा, नीचे feldspar नहीं रहेगा. For lithosphere is the rigid outer part of the earth. लिथोस्फीयर मतलब सॉइल, इसके अंदर क्रस्ट और अपर पार्ट ऑफ मैंटल आता है. दिस इज अ क्वेश्चन. लिथोस्फीयर को टेक्टोनिक प्लेट्स में डिवाइड किया हुआ है और इन टेक्टोनिक प्लेट्स की मूवमेंट की वजह से कहीं कहीं पे अगर ये टेक्टोनिक प्लेट्स साथ में आ गई हैं तो ये ऐसे राइज कर जाएंगे तो माउंटेन बन जाएंगे, और अदर टेक्टोनिक प्लेट्स दूर हो रही है तो वहाँ पे अर्थक्वेक बन जाएगा, तो वहाँ पे फॉल्ट बन जाएगा. सो दिस इज फॉल्ट, दिस इज फोल्डिंग. यू शुड रिमेंबर हाउ इट हैपन्स. अब जो सोर्स ऑफ हीट है, जो अंदर से रेडियो एक्टिव डीके से प्राइमरीली जो हीट आ रही है, दिस इज अ प्रीमॉर्डियल हीट. जो प्लैनेट के फॉर्मेशन कहाँ से आ रही है, रेडियो एक्टिव डीके, यूरेनियम, थोरियम, पोटेशियम इन अर्थ क्रस्ट एंड मैंटल. दैट वाज ऑन अबाउट लिथोस्फीयर. फॉर द मैंटल, मैंटल इज द 83% ऑफ द अर्थ वॉल्यूम. अगर आपको याद है तो क्रेस्ट इट वाज 1% इन लेस देन 1% फॉर द अर्थ मास, जबकि for mantle it is 67% of the earth mass. It extends from Moho's discontinuity to a depth of 2900 km, not a point which you can remember also, so better leave it. The composition is rich. It is composed of silicate rocks. The composition is rich in iron and magnesium. So for the crest we remember Cr, for the mantle we remember Sima, that is magnesium and silicon. So iron is there here, magnesium quantity is more related to the overlying crust where aluminium quantity was more. Okay, now coming for asthenosphere. So this mountain has two parts, that is upper part is asthenosphere. The upper portion of the mantle is called asthenosphere. Astheno means V. कोई भी चीज ऊपर it will be V. It just lies below the lithosphere, extending up to 200 kilometers. It is very highly viscous. These mechanically weak and ductile, and hence इसी की वजह से टेक्टोनिक मूवमेंट्स के अंदर एडजस्टमेंट्स हो पाएंगी. कोई पार्ट एलिवेट हो पाएगा, कोई पार्ट डिप्रेस होएगा, फोन्स बनेंगे, फॉन्ट्स बनेंगे. सो वेरी इजी कॉन्सेप्ट कि जो ऊपर वाला पार्ट है वो विस्कस होएगा, तभी जो नीथोस्फीयर या जो क्रेस्ट है उसमें आपको कुछ लैंड फॉर्म्स देखने को मिलेंगे. द मेन सोर्स ऑफ मैग्मा दैट फाइंड इट्स वे टू द सर्फेस ड्यूरिंग वॉल्केनिक इरप्शन, इट इज asthenosphere. कमिंग फॉर द आउटर कोर, कोर इज डिवाइडेड टू टू पार्ट्स, आउटर कोर, इनर कोर. जो इनर कोर है उसको सराउंड करता है हमारा आउटर कोर, which lies from 2900 km to 5100 km. For mantle it was 200 km. The outer core is composed of Nephi, that is iron and nickel. So this is also composition. तो अभी तक हमने crest का composition देखा, it was Cr. For mantle it was Sima. So M for mantle, M for magnesium, and for core we say Nephi. Okay, and trace amounts of nitrogen elements. The outer core is not under enough pressure to be solid, so it is liquid. जबकि inner pressure, density increase, pressure increase, so it is so much that it is complete solid. Okay, inner core from center of the earth to 5100 km below the earth's surface. Here also Nephi is there. Earth inner core rotates slightly faster needed for the rotation of the earth. And other question, if anything is there, so there are some seismic discontinuities where seismic waves behave are not different compared to the surrounding regions because of the change in the physical and the chemical properties. Because density is increasing, temperature is increasing, pressure is increasing. Okay, so one is the Moho discontinuity जो crust और mantle के बीच में होता है. Asthenosphere because it is very ductile part, mechanically weak, viscous, तो landforms बन सकते हैं. And then Gutenberg discontinuity, which lies between the mantle and the outer core. And I remember that this is some question which was asked in UPSC somehow like before 2000, like 1995 or 1999. So this is a question which has been asked. So better you study where some discontinuities are there. Moho is in crust and mantle. M for Moho, M for mantle. Asthenosphere, you know it is the ductile part of mantle. Gutenberg discontinuity from mantle and the outer core. So core you remember. How you write Gutenberg? G you write like this now, so C. So it is core. Okay. Now this finishes our first chapter, that was layers of the earth. We are now moving towards second chapter, Earth's magnetic field. We'll cover this in the next video.